All right, ladies and gentlemen, I'm going to go over the conceptual questions on your Unit 1 problem set. I'm going to start with number 5, simply because numbers 1, 2, 3, and 4, those are definitions that you can get from your notes, or you can look them up in a book. You really don't need me to spell those out for you. If you do, you can come see me individually. Okay, so question number 5, explain the difference between speed and velocity. Well, recall that speed, let's see here, is a scalar quantity. So that means it only has a magnitude. So speed tells how fast something is moving. Let me erase these squiggles. Here we go. And then velocity is a vector. Okay. And so since velocity is a vector, velocity tells, or indicates, it's better, how fast and in what direction an object is moving. Okay, so speed is a scalar, how fast tells how fast something is going, velocity is a vector, tells how fast and in what direction. Okay. Next question, distinguish between distance and displacement. All right, so this is kind of similar to the last one in that one is a scalar and one is a vector. So distance is a scalar quantity, and distance is just how far an object moved. Okay, displacement is a vector. Okay, so displacement indicates how far an object moved from its starting position. Okay, so displacement is how far an object is from where it started. Distance is simply how far an object went. Distance, let's add this in. Oops, okay. Has to be positive. You can't go a negative distance. Displacement can be positive or negative. Okay, remember, if the object goes to the right of where it started, it's positive. If the object goes to the left of where it started, then it's negative in terms of displacement. Okay. Number 7, a NASA team at Cape Canaveral. The NASA team hops on the plane, travels to California to supervise the landing. A week later, which group of people, the astronauts or the NASA team, had the greater displacement? Explain. All right, so here you get to see my horrible drawing skills. I'm going to try to sketch the United States, and it's going to be awful. I'll tell you that right now. So it's like that. Here's the East Coast. Here's Florida. There's Texas. I don't know. And here we go. So that's how I think the United States looks. That's kind of sad. All right, so here we go. So here in Florida, this is the start for both the astronaut and the team. Okay, and then over here on the West Coast is the end point for both, can't really see my R there, the astronaut and the team that's there to help them, I guess. So if we look, we see that they both start in Florida. Oops, hold on. And they both end in California. So this question was trying to trick, well, there's no such thing as a trick question, because if you understand what you're doing, you can't be tricked. So what this question was trying to get you to realize is that they're both starting from the same place. They're both ending at the same place. So their displacement is the same. Okay? So the displacement is the same for both, I'm just going to call them groups. Okay? The reason that it's the same for both groups is because both started at the same point, the same place, and ended at the same place. So displacement doesn't care that the astronauts went into outer space and did whatever it was that they did and then came back. That's not important in terms of displacement. If the question asked which group covered the most distance, then the astronauts would be the answer. But since the question is about displacement, they both started at the same point and they both ended at the same point. So their displacement is the same. Okay, next we have a, let me change that. It shouldn't be a D. It should be an X, because this is a position versus time graph of two people running. So it says, describe the position of runner A relative to runner B at the y-intercept. So the y-intercept is just our y-axis right here. Okay, so we can see that runner A has a head start. Okay, it's starting further up the race, I suppose. So you could just say that runner A has a head start. And I think we all know what that means. Has a head start. Okay. Which runner is faster? Well, runner A had a head start, right? So here's runner A with its head start, but you can see that runner B passes runner A. So runner B has to be faster. Okay, runner B is faster because he passes runner A. And then the question asks, what happens at point P? Well, point P is supposed to be right here where there's that intersection. Okay, so at point P, runner B passes runner A. All right, that's that. Not much to that one. So let's move on. All right, so next question. What quantity can be calculated from the slope of a distance time graph? So a distance time graph, you're going to have distance on the y, time on the x, and so there's your slope. Okay, remember that slope is equal to the change in y over the change in x. Well, in this case, our y-axis is distance, and our x-axis is time. So when you have distance over time, that will tell you that the slope is equal to speed, because speed is distance divided by time. Number 10. What quantity can be calculated from the slope of a position time graph? So a position time graph is when you have x over t and you have some slope. So again, just like before, slope is equal to the change in y over the change in x. Now I realize that this x over here can be a little confusing, but remember that this x is not representing the x-axis. This is the symbol for position, which is the same as displacement. Okay, so in this case, this x is not representing the axis, it's representing the symbol of the variable position or displacement. So slope is equal to our y-axis, which is our change in position over time. Change in position over time is the definition of velocity. Okay, so don't let this x confuse you. It's not the x-axis. It is this x is the symbol for a position or a displacement. Okay, number 11. A person is riding a bike. Can a person have constant speed and changing velocity? Yeah, that can happen. Absolutely. Yes, if the person is moving at constant speed and changes direction. Okay. Remember that velocity is direction plus speed. So anytime you change direction and or speed, you change velocity. So if an object is moving at the same speed in a circle, that object is changing its velocity without changing its speed. Okay. Part B, can an object have constant velocity and changing speed? No, cannot. No, if you change speed, then velocity changes also because of the definition of velocity. Velocity is direction plus speed, or speed plus direction. All right, so that puts, oh yeah, that's it. That's it for 5 through 11. I hope that helped, and you can ask me any questions over this in class. I'll see you later.